Hey, everybody. Welcome to episode number 167, in which we're going to share some pretty neat EKS kettle tips that were recently updated in EKS kettle, which I think are pretty cool because basically it means that with EKS kettle now you can actually control what add-ons are being uh, installed into your EKS cluster, and you can then kind of have a little more freedom to do interesting things. So I think that's pretty neat. We're going to jump into that here in just a minute as soon as we get through the news. Let me bring up my screen here. Do I like that better. No, I like that better. No, definitely like. Nope. Where did it go? How about that one? Yeah, it kind of sucks. I'll find it one of these times. Let's go with that. See how that is. All right. So the news of the day. Oh, one of the things I wanted to point out was that this week a lot of people are getting their notices about whether they have been accepted or not accepted into the amazing KubeCon in London, coming right up in 2025. Starts in 71 days. It will be happening in London. Super exciting stuff. If you have never been to Rejects, this is my reminder to you that Rejects is an absolutely incredible conference. And as soon as the notices come out, that's when the CFP opens. So you can see already, if you click on CFP, that the CFP is open and you are happy and you can actually submit a talk. But and even more importantly, you can also participate by volunteering, and you can register your interest with this form. So if you want to volunteer for Rejects, you can actually do that here as well. So just an absolutely incredible conference. You can get there a couple days early for the show, and you really get to see, in my opinion, some of the most top quality talks I've ever seen. Here's an incredible picture from Rejects in, wow, it just refuses to go up there. Come on now. Window. Move. Mhm. Oh, I see. That's why. 'Cause I'm in full screen mode. Okay. So this is a great picture, a great photo from Rejects just this year. You can see lots of smiling faces in there. Everybody just shows up from the community and is a part of the show. So if you have a chance to go, you should definitely take that chance. There's just so many awesome people to meet and to hang out with. I cannot say enough about it. All right, that's my announcement for Rejects. Definitely come be a part of it, whether you're just volunteering or whether you want to get a talk that was rejected into it. It's just an incredible B-Sides conference. Other news, there's actually a pretty interesting white paper out there about leveraging ACI and Cilium, kind of the best of both worlds. I thought that was pretty neat. So if that's your thing, definitely check out that article. We have the most recent newsletter, number 73, the first one of the year, which released on 14th January. And Mr. Bill is at it again. He's actually just about to finalize the schedule for Cilium Con. So there's lots of stuff, great stuff happening in London coming up. There's a number of eBPF research papers that dig into things. And then, the eBPF verifier. This is actually a pretty cool project that was just announced kind of by the Polar Signals team. Bunch of good friends over there, including Frederick. And what they were looking at was they were trying to determine how much of their traffic is actually pod-to-pod traffic is actually crossing the zone inside of an AWS cluster. And the reason for that is that AWS charges you more for traffic that crosses zone boundaries. And while Isovalent and Cilium, I should say, actually has had for quite some time the ability to ensure, like to prefer that traffic stay within a zone, there hasn't really been a mechanism within Cilium to actually measure how much traffic doesn't actually match that requirement. So they wrote this. They wrote this thing called KubeZonet, which is basically a way to measure. Um, packets that are actually destined for within the zone or destined with it that would actually cross the zone so that they could actually determine how much of that traffic was happening. There are some limitations because this is actually pretty specific to the environment in which they're running. They're actually using the net filter program support, which means that you need to be running a pretty recent kernel, like a 6.4 kernel, etc. But really cool stuff. Really neat project. I like that a lot. Great seeing companies work together on solving problems like this. But I do think that eventually that might be a little easier in Cilium. Just at the moment, this is what they need to do to get that done. Interesting article around trace points, K probes, and F probes. These are 3 different ways of actually instrumenting the Linux kernel. Oh, we have some comments. Hello, Joseph. Glad you're here. And then we have T-verse. Is Cilium looking for contributors? Yes, we're always looking for contributors at Cilium. In fact, I'm pretty sure that if you go to github.com, well, and you spell it correctly, Cilium. And I think we have a label inside of issues, which is good first issue label. So here's a great way to get started, right? A lot of these good first issue labels are meant to be consumable, approachable issues that you could actually contribute to. So if you do want to contribute to Cilium, we would jump right in there. And then there's a couple other things I'll share real quick for people who are interested in contributing to Cilium. Obviously, in the root repo, there is a contributor guide, how to actually go about doing your contribution. I believe it is here, contributing. So there's a whole bunch of information here, how to set up your pull request, who to chat with, Cilium feature proposals, which are ways to actually express like different features that you want to get into the project, all of that stuff. There's even a clone and provision environment, so you can do your testing, the contributor ladder. There's a certificate origin that you have to sign when you're actually a committer. You can even contribute as a reviewer instead of a committer. So depending on what you're trying to do, there's lots of really great opportunity in there. But specifically, I definitely will point out that the Cilium Slack is also another great place to start. So if you go to slack.cilium.io, you can jump in there, and there'll be daily, there'll be contributors to Cilium that you can ask questions of directly. So yeah, jump in there. We always need the help. It's awesome. All right. There's just a ton of content out there for contributing to Cilium. So feel welcomed. I mean, you should really, if that's something you want to get into, it's a really great project to actually contribute to. All right, get back to our news here. So trace points, K probes, and F probes, different ways of actually instrumenting the kernel and with different limitations for each. And I thought this was actually a really well written article that kind of gets into each of them. So if you're interested in understanding the difference between these things, definitely go check that out. There is a a project that's now in Kubernetes 6 called Ingress to Gateway, which is a tool that will take your ingress resource as defined and give you a gateway API resource defined in a similar way. Now, obviously, gateway API is a superset of what Ingress can do, so it wouldn't match directly. But like, if what you're trying to do is just kind of get started, like migrate Ingress objects to gateway API, this is a good way to do that. Lots of interesting stuff out there. I thought this was an interesting one. This is a Rust project that leverages eBPF, that looks for threat hunting tool for Linux and leveraging eBPF for kernel level probes to capture critical events. Some really good information from the news stack, talking about the CrowdStack outage and talking about eBPF being a much safer tool for solving some of these problems. The observabilities, or the ollies, for 2024, we win for the best Kubernetes tooling policy and configuration. That was pretty exciting. Lots of end of the year wrap up kind of stuff. A great release about why Reddit chose Tetragon. The eBPF verifier errors project. But the project is meant to like kind of try to make the verifier errors a little easier to understand. That's pretty good stuff. What else did I want to show you? Unlocking cloud native with Cilium and eBPF, Cafe. This is a good one. Overcoming Kubernetes IP address exhaustion with Cilium. So this actually gets into the different IPAM systems, the different IP address management mechanisms that Cilium supports. And for the first one, of course, it can rely on the IPAM that actually comes with Kubernetes. So there's an IPAM mode called Kubernetes where it will actually take into account just the IP addresses that Kubernetes would allocate to the node and then allocate IP addresses from that. But there's a lot of other options, which this really gets into, like cluster scope IPAM mode. Cluster scope is actually where we do the IPAM. We don't rely on Kubernetes to provide it. And since that's a deprecated feature in Kubernetes anyway, that's probably a better option for most folks. And you can specify how big you want the pool to be when allocated to a node, etc. And then and we start getting into the really fun stuff. Like there's actually some pretty cool stuff around multi-pool IPAM mode, which came out in 1.14. In this particular regard, you can actually create different pools of IP addresses and then associate them by name with particular workloads. So for example, here's an Nginx deployment. And then in here, you can see that the annotation is IPAM Cilium.io IP pool Mars, and the other one does not have that annotation. And so you can see from the output that these Mars deployments will actually have a different IP taken from a different pool. So pretty cool multi-pool functionality. We could definitely dig into that a bit in one of these episodes. But the other thing that's neat about the multi-pool thing is that it will pull another CIDR if it doesn't have enough IP addresses to actually allocate. So there is a multi-network lab that gets into that feature and all of that stuff. So pretty neat features. Maybe we'll cover that one in the upcoming Cilium or in the upcoming eCHO Opposites hours. What do we have here? From LinkedIn, we have a comment. I had once a Kubernetes cluster with Cilium replacing kube-proxy, but when adding a new node, it wouldn't become ready. I figured out reinstalling kube-proxy was required to allow the node to get ready. That's interesting. I'm not sure why that would be. Oh, I think I have an idea. We'll talk about it when we go through this demonstration here in just a little bit. I think I understand why that would be the case, and we'll talk about it here in just a minute. We just hosted a really incredible webinar with my friend Christopher called DNS Troubleshooting Made Simple. And we dig into like how Cilium and ekcstl help in understanding DNS troubleshooting. There's an upcoming hybrid cloud seminar, Cilium-powered microsegmentation for VMs and containers, where you can learn a lot about the microsegmentation as it relates to things like KubeVirt. There's an eBPF dev room that has been announced for FOSDEM. There is a BPF conf coming up, and of course, our own Cilium Con in EU will be coming up. All right. I think that covers everything. Let's jump into the next section. All right. All right. So the next thing we're going to do is I wanted to point out that in the EKS Kettle docs, they actually cover this. So like right at the top of the EKS Kettle docs, you can see there's been some announcements. Oop, hello. Hi. Oh, that was weird. Right up at the top of the docs, you can see some announcements. For example, EKS Kettle is now fully maintained by AWS, which I think is actually pretty cool. EKS Kettle now supports cluster creation flexibility for networking add-ons. And when you click on that, it takes you to the section where this actually all happens. When a cluster is created, EKS automatically installs VPC CNI, CorDNS, and kube-proxy as self-managed add-ons. To disable this behavior, in order to use other CNI plugins like Cilium or Calico, EKS Kettle now supports creating a cluster without any default networking add-ons. So to create such a cluster, set the add-ons disable default configs, such as this one. And to create a cluster with only CorDNS and kube-proxy and not VPC CNI, specify them after the default. So what this does is it sets the default configuration to none, and then any add-ons that you list after that will then be added to the cluster. However, if I were to create this, and we're going to walk through this, but when I create this cluster, this control plane, even if I were to add nodes to it at that state, they would never become ready because there's no CNI to actually allow them to become ready. And this creates a little bit of confusion because it means that when you're defining a cluster, you have to actually do it in a different order than you would normally do it. So let's walk through that as a set of tips, and I'll kind of show you what I mean, and we'll dig into the detail here. So we are going to use ekcstl for this. So if I have AWS Vault set up, uh, put my information in, allow. Oop. All right, so now I'm in AWS. I've got my AWS credentials loaded up. They're in my environment, etc. So now at this point, I can do things like, ekcstl get clusters. I can see I already have a cluster deployed, but we're going to deploy a different one to actually try this as part of this demonstration. And to do that, if you want to actually access the content that's here, I have shared it. And so if you go to hackmd.io/echo-live, number 167, you'll be able to see this content. It says Ghosty, yeah. I actually kind of like it. It's pretty cool. Yeah, actually, those of you who have been following me for a while might also realize this is a Mac. And I was just decided, I have enough into the Mac ecosystem for a while that I decided I wanted to just try out another Mac. So I got myself a new MacBook to give it another shot. And so far it's working for me. It's actually less irritating than it has been in the past. So overall, I'm actually pretty happy with how that's all going. So let's go ahead and grab our cluster YAML. We'll move into a directory. We'll call it Echo 167. We'll create our cluster YAML. Paste. Cluster YAML. Now what this is going to do, you'll notice I don't have a node pool defined. This is what I meant by the order of things. If I define a node pool here, the cluster will never reach a running state because the nodes will never become ready. So instead, I have to do these things in a two-step process. I have to create the control plane. I then have to install Cilium if I'm going to, and then I can actually create the node pool and associate that node pool with the cluster. But in this configuration, as we're looking at it here, it's not going to create a node pool by default. So let's go ahead and get that started. Cluster F cluster YAML. What are you complaining about? Oh, bin cluster YAML. Eh, it is version, isn't it? Oops. Close my ghosty terminal. Give me 1 second. Let's that up a little bit. I'll make sure I have this correct here. Look at a working example. Oh, I got to put it in quotes. I see. Okay. So, that was my bad. Let's go ahead and edit our ekcstl 67, cluster YAML. Now that should work. So ekcstl create cluster config cluster YAML. All right, we're off to the running. We can see already from this output that things have been configured correctly, right? So it says there's one task, create add-ons, wait for the control plane to become ready, associate IAM OADC provider. This cluster is going to be the create the cluster control plane demo ekcstl. That was because that was what we actually named it in the config. So away we go. Hopefully the AWS gods will be nice to us today so that we can kind of get through this pretty quickly. And then we can keep going. Oh, what will I do during this time? Do you think it will actually take so much longer that it actually completely blocks me out? I hope not. But we should see. But we'll see. We'll see. You know what I could do, which I'm actually kind of curious about, but it would also be EKS related. One of the things I could do is I could spin up an EKS cluster leveraging Terraform without the add-ons. Because that's really the thing I was super curious about. And what my research has told me is that in Terraform, when you're interacting with EKS kettle, or when you're interacting with EKS, you still have an add-ons section, and you can just not set particular add-ons, and you'll end up with no add-ons installed at that point. But then you have to go through the next module, which would actually install a node group, etc. So that's the part I haven't dug too far into yet, but I think that would actually work. What do you think, folks? Do you think we should do that? Think I should actually spin up a Terraform configuration and kind of get that going as well? Or should I just wait for this to happen? One of the nice things about um, Ghosty is that when you have a font setting, it'll actually copy that font setting to the next window. So if I split like this, I don't end up in a state where it doesn't actually work. So here's our EKS kettle cluster, still in create in progress. All right. Back. Should be coming along here pretty quickly soon. Shouldn't be too much longer, I don't think. It's wrong cluster. There we go. All right. So now we're getting the add-on set up. Filters. Demo ekcstl. I see. Okay. Go. We should see no pod. We can see coordinates there. That's good. So we do ekcstl get add-on pictures. Plugging away here. Looks like we're in pretty good shape. So we are able to talk to the API server. We're able to see the add-ons being created. We're able to see that the cluster is in an almost running state. Our permissions are set up. Now going to add the permissions for the AWS EBS CSI driver. And then we'll be all good. But what's neat about this is that we can see, even just from this output, that there is no kube-proxy, there is no AWS CNI, that these things did not get deployed. And even this will eventually succeed because it has marked the deployment of the add-on complete, even though it's not in a current running state. So let's keep watching what happens here. Things are really moving along. I probably didn't need to do the storage add-on for this particular demo, but let's keep it going anyway. All right. Okay. So now my cluster is there. And obviously, if I were to do kubectl get nodes, I would see no nodes. And I would see kubectl get uh, pods-aw. I can see only the two add-ons that I created, CordianS and ABS CSI controller. So if we look at our cluster.yaml again, we could see those are the only two I added. The others did not get added. So this feature actually works pretty cool. Like it actually does allow me to control what's going to happen here. So next up, let's go ahead and configure Cilium for this cluster because we want to make sure Cilium is there so that when we add we add the node pool, the node pool will actually get Cilium installed on it, not the AWS EKS cluster. However, this takes a bit more work because we need to figure out some things first, right? So for example, we need to know the API server. We need to know what the API server address is. So let's take a look at the output of this command. I'm going to paste that in here. Add some export lines. The reason I'm doing it with DRM is that DRM will actually allow me to automatically create it. If I move out of this directory and then move back into it, it'll actually export that stuff. So if I do echo API server host, I can see that's the actual that's the FQDN of the API server host, and then the port is there as well, port 443. And that's all because of this nvar-c here. So as soon as I move into the directory, DRM, which if you have not seen, I definitely recommend you check out. I use it for so much stuff. But if you go to DRM, I believe it is .org or something like that. No, maybe it's not DRM.org. Net. There it is. DRM.net is the docs for it, and it really kind of shows you how all of it works. But if you have anything that actually leverages environment variables for its configuration, then DRM is super useful. Okay, so with that information, we can now configure Cilium. And the reason, and this is where I think my theory is coming in for your problem, Arezki, which is that Cilium, by default, if it installs in an environment where kube-proxy already exists, then it will leverage Kubernetes to determine how to go and talk to the API server. It'll leverage kube-proxy to go talk to the API server. If it doesn't already have that, then that initial link, that very first time Cilium or kube-proxy talks to the API server, that never happens. And that means that as you add new nodes, if there was no kube-proxy for Cilium to actually go and configure this, then it would never know how to do that. So the way that we're going to configure Cilium will be a little bit different than perhaps the way that you did it. And I'm going to show you the difference here in a second. So let me go back to my notes. We're going to grab this config, and we'll go ahead and drop that into our directory here. So this is the Cilium values that I'm going to use. So in my Cilium values, I'm actually going to enable IPAM mode ENI, and this basically means that, and the ENI mode for Cilium. And this is going to enable it such that Cilium will actually be able to use the ENI mode that AWS exposes. And then I'm going to turn on Hubble. I'm going to turn on Hubble Relay. I'm going to enable the node init. I'm going to set my devices to the Ethernet devices on the nodes, setting my routing mode to native, and setting my kube-proxy replacement to true. And then that's where the environment variables came in, and they got populated here as well, which means that my K8 service host is configured and my K8 service port is configured. And when I configure these two, what I'm doing is I'm telling Cilium to go ahead and just use those two, the host and the port, as the way to talk to the API server. And this is important in this case because I'm actually using kube-proxy to replace, I'm actually using Cilium to replace kube-proxy. I didn't install it in the cluster, right? So if I do kubectl get ds-a, you can see there is no kube-proxy deployed. There's only core DNS. Kubectl get pod-a, right? Only core DNS is installed. There's no AWS CNI and there's no kube-proxy. So in my configuration, I'm actually going to tell Cilium to do to do that work, right? Explicitly, I'm saying kube-proxy replacement true, and I'm actually going to go ahead and configure this so that when Cilium tries to replace kube-proxy, it knows how to talk to the API server without an already existing kube-proxy in place. All right, so at this point, we could do our Cilium install values, point to our Cilium values. And if we do Cilium status watch or wait, then we can actually see Cilium doing its install. Those will never actually become ready though. That'll just sit there forever. So, but that does tell me that Cilium has been configured. If I do kubectl get ds-a, I can now see the Cilium envoy, and the Cilium node init have all been added to my stack. Next up, we want to add a node pool. So let's do our EKS. I'll create node pool, node group, cluster. Demo EKS kernel. Not enough information. We'll take the defaults for the rest of it. So let's get that deployed, and that I think will create, I don't actually remember how many it will create, but it will create a node group for us inside of that, associated with that cluster. And then we should see that there are no, that Cilium is still deployed, that none of the rest of that stuff just magically showed up, that we're in a place where things are now ready to be scaled up and made use of. Because I didn't give it a name, it's just going to pick one for me. Obviously, a ton more parameters that you can actually pass to a node group, but in this particular regard, it's just this one. So see if we can get this going. Just booting up, bootstrapping our node here. Down below, I do AWS, actually ekcstl, get node group. There it goes. All right. So it has two nodes. I now do kubectl get nodes. I see they're both ready. That's a surprise. Kubectl get node, get pods -aw. You can see all of the things running, and only those things that we expect to be running are there, right? So Cilium has been deployed. We see core DNS. We see our EBS CSI drivers. We see Hubble Relay. The cluster is up and happy, working just as we would expect. And I could even do Helm install. Say isovalent was app dash actually. And then I'll just deploy like a sample app to the cluster. Pods dash and jobs. Make sure that all gets deployed. And at this point, this EKS cluster is configured such that it will never add those other things back in. It'll just keep operating the way it is. I could add more node groups. I could change the size of those node groups, scale them up, scale them down. I don't have to do any labeling or tainting, because the only thing that we'll actually configure in this cluster is Cilium as defined. Oops, what happened there? I see it's a managed group. They're using M5 larges, and I can scale it up or scale it down. So I can do AWS, I can do EKS kettle, scale node group, and grab the name of it. Oh, scale node group. I copy the wrong thing. That was weird. cluster demo ekcstl nodes equals 5. Nodes max equals 5. No. And then let's watch these three other nodes come in. And then we should be good to go. Oh, I know what's happening. I forgot to do this part. Get storage classes. So that's my GP2. And is it the default? No, it is not. So we need this. We need to annotate it. Annotate storage classes. There's our 3D nodes. All right. We want to change GP2 to be the storage default. Get storage classes. There we go. Now it says the storage class is default. There's a way to actually do that in the config when you're booting it up. And I don't remember what that way to do that, but if I need to get pods -n jobs. Start deployment jobs app. It should come out of pending now, I think. See if this clears us all up, and then we should be good to go. Oh, there's anti-affinity rules. There is a default storage class. And I'll get PVC. Okay. There's the Elasticsearch. It's pending. Oh, I guess they haven't provisioned them yet. Gotta wait for that to actually go through. But anyway, this is all working. So we got that all happening. So if I were to do kubectl, run it, bash equal bash. Oh, I think we forgot to make these public. Whoops. But yeah, that's what I wanted to show you. It's working pretty well. It's a pretty neat way of actually managing these clusters. But yeah, best way to get started on Cilium. Do I need an actual cluster or Minikube enough? Minikube is totally enough. You don't need to actually do a whole thing. In fact, you can even do this with kind, which is very cool. Let me actually show you that real quick. First, I'm going to go ahead and delete this cluster. Delete cluster, EKS. We just got a demo. Yep. My dyslexia is really having a lot of fun with me today. So there we go. So that's going to get that deleted. And then before I go, I'm just going to show you this real quick. So if I do cat kind and KP. So here's an example of a kind cluster. Got one control plane node, one worker node. I'm disabling the default CNI and I'm setting kube-proxy mode to none. And when I create a cluster, actually, can I do that? Yeah. When I create a cluster that's configured like that, dash config, kind MNO KP, cluster. I'll actually stand up a two-node cluster with everything deployed. I definitely prefer kind over Minikube, yes. Although they're both very powerful. I spend a lot more of my time with kind because I feel like it's pretty configurable. And I know the people on the project, and I'm a big fan of kind in general. Kind is actually used to do a lot of the testing of all of the Kubernetes PRs that happen in the Kubernetes project. So I'm a big fan. If you want to learn more about kind, you can go to kind.sigs.k8.io. This is where you can learn a lot more about it. It's also where you can get into contributing to it if you want to do that. Like, there's just a lot of really great stuff about it here. So it's going to stand up. It's going to leverage kubeadm for the provisioner, and it's going to stand up two nodes. The nodes are actually running as containers, so they're not like it's not a virtual machine abstraction like Minikube is. So if I were to do Docker PS, I can actually see the two nodes running here, kind worker and kind control plane. But if I do kubectl get pods -aw, I can see that, again, in this scenario, because it's using kubeadm, I see etcd, I see the API server, controller manager, the scheduler, all those things are running, but there's no CNI installed. And then just to get started with Cilium, I can actually just do Cilium install, and it will auto detect that it's a kind cluster. It will auto detect the kube-proxy hasn't been installed and configure Cilium to do that work instead. And it will also detect the API server and the port. Now if I do kube get pods -aw again, you can see Cilium is installing. It'll take a minute to download and stuff, but basically, yeah, that's a fully provisioned Cilium cluster ready to go. If I were to do Cilium in Hubble enable, this will actually deploy Hubble, and then Cilium Hubble enable --UI will install the next component. Yeah, off we go. All right, y'all. That's what I wanted to share with you today. I hope that was useful. I find it pretty cool that ekcstl actually supports that, and that that's a feature of the project. So I hope that was useful. I hope you all have a wonderful weekend, and I will see you next time. Thanks for tuning in. Bye.